Hi Shubham.
Hello.
Sorry, we had some technical glitches. Hope you're able to hear me now,
Yeah.
and
I'm able
we
to
are
hear
able to hear you as well. So let's get started.
you. Yeah. So, shall I start the session?
Yes, please. Sorry.
Okay. So, thank you for inviting me on this channel. We'll be seeing how a lithium battery pack works as well as it is manufactured. Okay. So, we will be going from a cell to a battery pack. Firstly, we will discuss about the cells. Cells are normal cells only, but they are of lithium type. So, one of the electrode is having lithium inside it. Firstly, a normal cell looks like this. This is a normal bunch of cells, okay, and it is having positive and negative on both sides. So, like a conventional cell, it will be having two types of polarity, positive and negative. Here in lithium battery cells, it is having a pressure vent. So, any type of thermal hazard or any type of electrical hazard happens, then it will be releasing the pressure from here. Okay. So, firstly, we will be discussing how these cells are tested. We will be getting the cells from the suppliers and we will be matching the overall specifications with the data sheet. Mainly, this process is called as grading.
I'm on
We'll
mute.
be dealing with mainly voltage, capacity, and the state of health in this stage. Then, after moving ahead, we will be seeing how such cells are working at different stages. So, there are penetration tests, and there are also load tests to get the exact capacity of the cells. Then these cells are connected to each other by using nickel strips. You can see nickel strips here. So they are used. Why nickel is used? There is a reason behind that. Nickel is having a high current carrying capacity. It is cost effective, and it is corrosion resistant. So that's why it is used in lithium battery packs. And it is the sixth abundant metal on earth. So the availability is not an issue there. So as per the specs, the cells are connected. So positive, negative, and whatever it is. So series parallel arrangement is done. So let us take an example of making a 36 volt and 10.4 Ah battery pack. Suppose these cells are having 3.7 volts and 2.5 Ah capacity. Okay, so they are having the volt value as 3.75 and the Ah value is
We have
2.5.
profile
Okay,
video on
so
system.
suppose we want to make 36 volt 10.4 Ah, we'll be connecting all of 10 cells in series. So 3.75 into 10 will be 37.5, and then we will be reducing that to 36 volts. And for the ampere hours, that is the capacity, will be having four parallel lines. So to increase the current rating or the capacity rating, we will be doing parallel arrangements, and for increasing the voltages we will be doing series arrangements. Okay, so suppose this is, you can see that they are connected in the positive is connected to the negative, then on the other side the positive is connected to negative, and so on and so forth. Okay, so like this only they are connected in series, and to increase the value of current they are connected in parallel. So for increasing the capacity, positive is connected to positive and negative is connected to negative to make whole parallel lines around it. Okay, so 3.75 into 10 is 37.5 and 2.5, so 10.4 h we will require. So for 10.4, 10.4 divided by 2.5, we will be getting around 5 value. So it will be around 4.5, 4.6, but we will be taking 5 as it is the maximum value. Then what we will be doing, we will be placing them in series parallel arrangements, and then we will be putting a sheet of insulation like this. So you can see how they are connected in series and parallel, and then we will be putting an insulation sheet around it. So this will be protecting them from outside electrical hazards or any type of impurity that is entering into the system. And what we have to take care of while arranging this is we have to continuously test the voltage and capacity of the battery pack we are developing. Okay, so as per the client design, we will be arranging them. so that it can fit into the electrical as well as the mechanical dimensions. Okay, then we will be covering the insulation sheet with the blue pack, that is a normal tape only, but we will be having a different type of sheet that is also an insulation sheet, uh, that is called as uh, blue colored film. So this is a kind of a film that is used for covering it. Okay, and then the branding and the overall specs is done right here. And what a battery pack also consists of is this type of connector. This type of connector is called as Anderson connector. So it is having a positive and negative, and it holds good when it is connected to any other female or male type connectors. Okay, after getting the pack ready, this is called as soft pack. So as per the demand on the consumer electronics and portable electronics side, we'll be providing them with these type of soft packs. Then we will be moving ahead with the mold type plastic or any type of enclosure which is required for that. So mainly electric two-wheelers and three-wheelers and the cars which you would be seeing, that also includes Tesla, MG Motors, and different kind of electric cars that are available right now. So in those type of cases, we'll be having a separate enclosure which will be having IP67 or IP65 rating, so that it is dust proof and waterproof. So this type of battery packs are used for two wheelers right now. Okay, so the specs is written, the overall what type of hazards can occur, and the terms of conditions and all things are written behind it. So this is the whole way of getting the pack ready. So firstly, one fundamental thing, if you want to develop any type of battery pack, firstly we have to see how what is the need exactly. So including the mechanical dimensions, the electrical specs, and the availability of the materials, these are the main constraints that any type of battery pack can face. Okay, so firstly you should have cell ready. They all should be graded properly, so the voltage, ampere hour, and the health should be matching that data sheet of the cells. Because in many countries, what they are doing, they are providing the cells but they are not providing the exact data sheet. So the data sheet is not matching the exact specs, so you can't get the performance which is desired. After moving ahead to the battery pack module, like this, you should check it that if it is having any type of impurity or any type of voids in between or not. So for that, cell holders are used. So cell holders are basically Lego type holders which are holding the cells from both the sides, so that they can't be affected by the environment, and it is safe to carry it anywhere. Okay, so that gives the portability factor for that. And then you have at the module side or the pack side, these type of connections, that we have to ensure that the spot welding is perfect. No impure short spot welding should be there. So you can see the distance between the cells should be same, right? If it is not same, then there will be a chance of electrical or mechanical hazard between that. And this, the battery pack assembly, this is called as the overall battery pack. It is having a positive, a negative, a connector, and a fuse. Okay, so for any type of battery pack, the fuse is required. Even if it is DC, we'll be needing the fuse for over voltage and over current protection. So what we are adding on the battery pack to make it more safe, right? So including any of the major companies, EV car makers right now, they are using battery management system, that is BMS, on every battery pack. So what BMS is doing, BMS is a normal chip that is connected to the battery pack. So the overall voltage protection, overall current protection, as well as the thermal runaway, and overall protection of the mechanical side, that is whole covered by the BMS. Sometimes the BMS are having smart capabilities that they will be showing your voltage and current on the screen right now. Okay, so you'll be having mobiles smartphones. Okay, so how you are getting the voltage indication or the health indication on the device, that is possible due to smart BMS only. They are having some type of CAN connectivity or Bluetooth connectivity, depends on the it solely depends on the manufacturer that is incorporating that. And BMS also includes the factor of communication. So besides protection, it will be communicating all the cells that if any cell is overcharged or over discharged, then what will BMS do? It will be balancing so that uh, all the cells should be charged equally or discharged equally. Otherwise, if any cell is overcharged or over discharged, then there will be chance of electrical hazard. So you might be watching various hazards happening around the electric vehicle sector. That is mainly, so 60% of the hazards are having BMS miscommunication as the probable factor for it. So that is the case on the BMS side. And after that, after including the BMS, the overall battery pack, what we have to ensure is to get the mechanical protection right. So ingress protection standards are set so that the clients or the people who are getting it should get uh, proper protection from the water, dust, as well as from the environmental problems. Okay, so these are the things that we have to take care of. On the consumer electronic side, lipo batteries are used. So lithium polymer batteries, because they are having low weight and they can carry they can carry more power or energy within small size. So they are having more energy density also as compared to lithium ion. Basically, lithium ion is having two types of variety which are used in electric vehicles and solar sector. One is NMC, as I have already told, that is nickel manganese cobalt type, and another one is LFP, that is lithium ferrous phosphate. Ferrous phosphates are looking like this only. Okay, so any lithium ferrous phosphate cell or any type of nickel manganese cobalt cells, they will be having standard dimensions. So the 18 will be their diameter, and 65 will be their overall length. Okay, so that's why they are called as 18650 cells. Okay, they are used in Tesla and Ford, BMW, all cars. Mainly 18650 are used. Recently, during the final general meeting of Tesla, they have introduced one new chemistry, or not a new chemistry, but a new type of dimension, that is 32650, where the diameter of the cells is bigger. So that is around double of this cell, and 65 is the length. Okay, so they have introduced that in the last general meeting, and it is having good communication with the BMS also. So that is all about that. So we were discussing about lithium polymer batteries. So what lithium polymer batteries are capable of is to have different kind of pulses which are perfectly suitable for the consumer electronics. So that's why they are used. So in the nickel manganese cobalt side, these type of cells are used, and on the LFP side, lithium ferrous phosphate, bigger cells are used. So that's why LFP cells are having 3 years warranty, and nickel manganese cobalt is having 2 years warranty. So this is the thing about the whole battery pack. If you are having any questions, you can raise it, and I'll answer them. BMS is a electronic device that is connected to the battery pack. It will be controlling the electrical parameters of the battery pack. Mainly, it will be providing over voltage, over current, and thermal runaway protection to the whole battery pack. So mainly, the hazards are happening due to voltage, current, or any type of thermal runaway that is happening into the battery pack. So it is one type of controller which is controlling the overall battery pack and keeping it safe from the fire hazards.
Okay.
What we are doing, we are a small startup based out of Ahmedabad, India. We are developing lithium ion battery packs and various other products. So we started with the battery pack. We imported the cells because the cells are not yet manufactured in India. We imported it and we started manufacturing it for the ventilators, because during the pandemic we were having demands for the ventilator side. We developed battery packs for them, and then we followed the demand on that side, and we got a good amount of revenue from them. And then we are shifting it to the tester side. So we are developing a universal battery tester right now, so that will be capable of telling the crucial parameters of any type of battery in the world within fraction of seconds. So this is the thing we are working on.
Okay.
Tesla and MG Motors and BMW, what they are following is they are using intelligent battery sensor, that is IBS, in communication with the BMS. So if any of the cell is behaving improperly, they will be getting the data on the software itself, software screen or the dashboard itself. So the user can change the whole battery pack or anything like that. But on the universally, what the main practice which is followed by even battery manufacturers. So right now Tesla is not into the battery manufacturing side. They are getting batteries from CATL and BYD from China. Okay, so what practice they are following is they are measuring the internal resistance of the battery pack or any cell they are having. So depending upon the internal resistance value, we can get the state of health. So how healthy is the cell or battery pack? Depending upon that, we can predict the normal life cycle or the calendar life of the cell. So normal life cycle, suppose the cell is specifying that 2000 number of cycles are possible, but when you are getting the internal resistance value, then it is showing that around 500 cycles are only possible by this. So depending upon that, you can estimate the number of years it can withstand. So right now, what the practice which is followed is to get the nickel and lithium out of it, and then after extracting it from the older cells, they are getting it. They are getting it into the manufacturing of different byproducts which are available from that side.
Okay.
So what we found during the meet with the battery stakeholders, that the battery tester should be simple. So any type of unskilled labor should be uh, capable of understanding it as well. Second one is should be portable. So it should not be like that a big bulky machine and which is kept aside of one room, and you have to take your heavy battery to that place and you have to test it. So that way it can't work, right? So we found that it must be portable, and second and the last one is it should be reliable. So while comparing our portable battery tester with the bigger one, the bulky one, we should be accurate enough to get the best reliable results possible. So that's why for that we are using some machine learning algorithms, uh, so that we can get the accuracy as well as reliability.